This presentation is about small footprint AutoSAR classic platform products. AVIN Systems Private Limited made a presentation in 11th AutoSAR Open Conference, held in Shanghai, China on 7th of November, 2018. The presentation was done by Mr. Venkati Sanvi of AVIN Systems. This video is a repeat of the same presentation. Provider of quality and safe solutions to automotive customers. Product-based company, supplies AutoSAR basic software platform and tools and associated services. Rich experience in automotive software, specifically in vehicle network platform and AutoSAR. AVIN products. AutoSAR ECUs. Small footprint basic software based on AutoSAR R4.2.2, AutoSAR COM, CAN, diagnostics. AutoSAR R4.3.1 basic software. ECU configuration editor and SWC editor. Bootloaders. AutoSAR adaptive platform. AVIN services. AutoSAR migration, integration, consultancy and training. Functional safety consultancy and ADAS services. AutoSAR and legacy networks. AutoSAR is a worldwide, de facto standard for automotive software architecture. Stable classic platform architecture for control ECU emerging adaptive platform for future needs of automotive software. For example, autonomous driving. AutoSAR is being used by many OEM networks in the European region. Asian OEMs are using non-AutoSAR solutions mainly. They have started to adopt to AutoSAR platform. Various scenarios of platform software adaptation are existing. OEM ask for a non-AutoSAR network. Tier 1 gives non-AutoSAR ECU. Platform software vendor gives proprietary software solution. This is the typical scenario for Asian OEMs. The next possible solution is, Tier 1 still make non-AutoSAR ECU, however buys COTS AutoSAR architecture software. The third possible solution is, Tier 1 makes AutoSAR ECU itself for future reuse, when OEMs migrate to AutoSAR network. Ultimately, OEMs have to migrate to AutoSAR network. Major questions while migrating to AutoSAR. Could step-by-step approach be used? What about cost? High-end micro? Feasible for small ECU? Need upgradation of existing technology or tools? Expertise available within company? Impact on planned project timelines? The diagram of AutoSAR classic platform architecture. Approach to support AutoSAR migration to small ECU. This is approach to support AutoSAR migration to small ECU. Combination of legacy modules and AutoSAR modules can be introduced. Within AutoSAR only required features are considered to keep the size small to fit for small ECU. Architecture. The small footprint architecture comprises of COM, PDUR of zero cost, DCM, CAN TP, OSEC NM, CAN interface, CAN transceiver driver. A simple scheduler was used in the ECU. Legacy NV drivers were used. In live RTE, a simple adapter for legacy application interface was created. This is simplified architecture of small footprint. Module indicated with blue color are R4.2.2 AutoSAR modules. The modules indicated with green color are non-AutoSAR modules. The modules indicated with grey color are wrappers developed to integrate with a non-Autosa application. Autosa ECU Configuration Tool. The ECU Configuration Tool provides harmonization support for network configuration in legacy format, as well as ECU extract XML format. COM signals. Signal groups. Types Boolean, uint 8, uint 16, uint 32, uint 8n, sint 8, sint 16, sint 32. Endianous little, big and opaque. Transfer properties, pending, toggle, TWR, triggered, TOC update bit, invalidation, COM IPDU, I-PDU, I-PDU group. Transmission and reception. Transmission modes periodic, direct, N times, mixed and none. Minimum delay between PDU, I-PDU callout, COM notifications. Success notifications, timeout or error notifications. CAN communication. Transmission, full CAN and basic, and reception, full CAN. DLC check. Controller and PDU modes, sleep and wake up, software filtering. Dynamic canodes, XCP use case, CAN indications. Bus off, indication support, slow recovery and fast recovery. Wake up indication, validation. Passive error indication. Indirect NM, node and network monitoring, diagnostics. Number of UDS services, 12 to 15. Half duplex. DTC functions, setting, clearing, FF data, debounce, heal, displacement. OEM specific extensions. Results. CAN plus COM plus NM stack of RAM, 300 to 400 bytes. Configuration constant 4 to 4.5 kilobytes and code 23 to 26 kilobytes. Diagnostics stack of RAM 550 to 700 bytes. Configuration constant 0.9 to 1.2 kilobytes and code 35 to 43 kilobytes. The above sizes are measured using RH 850F1L 32-bit compiler, Green Hills. Conclusion. Autosa could be used for small ECUs of Asian OEMs. Autosa architecture enables interfacing with legacy components. Autosa stack footprint could be reduced significantly by scaling down the features. Autosa stack with low footprint is achieved without affecting Autosa architecture, tools and methodology. As the next step, migration to full Autosa architecture is achievable easily. Thank you for your attention. For further details, please contact AVIN Systems Private Limited at info@avinsystems.com and indersales@avinsystems.com.